Okay, our previous video stopped at this point, and we were about to provide the answer. Remember, the instructions here for these problems it's really a two-part answer. We need to identify the vertex of this parabola, and then the AOS in linear equation form. So let me see if Jake can give me the vertex. 0, 4. Okay. And I'm going to get Cody. Can you give me the AOS?
0.
X equals 0. Yes. All right. Any questions about those two parts of the parabola? All right. Again, you don't have to write this down if you'll just observe, and then you can go back and watch this if you need to. Problems 13, 14, and 15, you're going to be provided with the graph of a parabola. And the directions say to identify the points corresponding to P and Q. In other words, thinking about the AOS as that line that splits our parabola up into two equal parts. That means that point P, in this case, has a matching point on the other side of the AOS. And we call that point P prime. So tomorrow I'm going to give you I'm going to read off, or I'm going to show you the answers to P prime and Q prime. That just means the matching point for P and Q. So this might be a little tough for you to see, especially if you're in the back, but here's my origin. Let's see if Emily, can you tell me the coordinates of this P prime? 0, 1. Okay. And then over here, this is called Q prime, the point that matches up to Q, same distance away from the AOS on the other side. Reagan. Okay.
-3, -2.
Okay. Very good. So you got two answers. Yeah.
How are you supposed to determine which one is P prime, which one is Q prime?
Well, you just look straight across. If you'll be given P and Q, so you just look straight across, and the point that's straight across from P is P prime. Okay. Anybody else? I just have one example of this. You'll have 3 of these. I want to spend the rest of the time on the 3 problems that are going to be the most time consuming. So you definitely want to make sure you follow what's about to happen. You know how to do this based on what we learned in chapter 3, but I need to get you so that you can set it up, and then you'll be able to use a familiar method. Okay, let me just set up what this problem is asking for. Picture these 3 points as points on a parabola. Okay, these are actually 3 points. If we were to look at the graph of a parabola, these 3 points would be on it. It's our job to come up with the equation that represents that graph. So it's kind of backwards. Here's a graph. What's the equation, or what's the function? Well, here's how we're going to find it. It starts with the standard form of the quadratic function that we looked at early on in this lesson. Okay? For each of these ordered pairs, obviously I have an x and a y. Each one of these ordered pairs, I'm going to substitute in x and y one at a time. So let me show you what that means. Taking the first ordered pair, y is 0, x is 1. Okay? I'm going to do that same thing with the next ordered pair. Y is -3, x is 2. And you can probably guess what I'm about to do next. The next ordered pair, y is -10, x is 3. All right, so far all I've done is take each of the ordered pairs that I'm given, starting with the standard form, and I've substituted in x and y from each ordered pair. And now I'm going to do what I call cleanup. Okay, for example, what is 1 squared? 1. And 1 times a is just a. 1 times b is just b plus c. I just have this preference. I like to write my equations so that the number that is equal to is on the right. I'm not saying you have to do this, but that's the way I'm going to set this up. Okay, simplifying or cleaning up this second equation. See if you can follow this. Let me know if you don't. 4a plus 2b plus c is negative 3. Is anybody not sure how I got from here to here? Okay. One more. Oh, I left off the squared. Remember, there's a squared in this standard form. Olivia, what would this be?
It would be 9a plus 3b plus c equals negative 10.
Awesome. Okay. I don't think I need to take the time to go any further because what we have is a 3-variable system. And you know how to solve these. I'm going to set it up for you, but using elimination, remember we have to create 2 pairs of equations, and we have to pick a variable that would be the easiest to eliminate. And which one do you think would be the easiest?
C.
Nick.
I think the top one would be easier.
Which variable, A, B, or C?
C.
Probably C.
Yeah, I would agree.
C.
So I'm just going to start this, and then I'm going to let you finish it. Okay? So underneath my red line, here are my 2 pairs. I'm going to pair up the first and the second. And you might want to go back if you're unsure about elimination in a 3-variable system. That's section 3.6. You can go back to your notes. I think there are videos out there if you need to review that. And we're eliminating C over here as well, so I'm just going to use that first equation again, paired up with the last equation. Okay, so I think you can go from here, but let me just give you a heads up. All right? Eventually, when you get this solved, you're going to know what A, B, and C are. But I don't want you to just let that be your final answer, because the answer says to write or find a quadratic model, meaning your answer should be standard form of a quadratic function. So when you find out what A is, I'm just going to throw out a random number. This isn't true, but let's just imagine that A is 6. Then when you start to write your answer, you're going to show this as 6x squared. Now let's just pretend that B is negative 4. Then you're going to drop negative 4 in here for B. And let's just pretend, again, these are not right. I'm just making up numbers, but I don't want you to stop with just finding A, B, and C. I want you to put them into the standard form. Okay? So that's what your typical answer would look like for these 3 problems, 16, 17, and 18. All right, is everybody clear on that?
Yes, sir.
All right, this is what you're doing. Okay, any questions? Shout out to 4th period. You guys did a great job.